Jimmy, back out here at Redington Beach. I'm with Mangrove Construction. Thanks for watching our video blog. We're going to be talking a little bit about what's going on here today. And if we pan around here, Derek, we're going to go ahead and take a look here at this piece of equipment. Okay, we're here with Jay. He's with Robbins Manufacturing. They're responsible for dropping these toothpicks off here at the job site. So Jay was just telling us a little bit about how these things are manufactured.
Yeah, they bring them in from the forest or wherever they cut them at, and they put them through a machine that takes all the bark and everything off, and then they process them and they put them in a big, huge tank, and they put 14 pounds of vacuum on it, on this tank. What that does is it opens up all the pores on the sticks, so it sucks all the moisture out of them.
Right. Dries them, but also takes the treatment into
and they also put it in a kindling tank, which is a real big heater, and it just dries them out. And then after they're done with pulling the vacuum out and getting all the moisture out, then they refill the tank full of the mixture that preserves the wood, and they put them in it. They flood it with like 1,000, 1,200 gallons of this fluid, and then they pressurize it down to like 162 pounds per square inch. That's kind of like what a submarine goes through.
Right.
So anyway, they just pressurize it, and when they're all done with it, then they take the liquid out and they let them dry.
So they're soaked. The idea here is to get these completely soaked with that
It's
material.
completely soaked. And they've got a room that will come and they'll drill a little bitty hole into the wood. And they can take that little bitty piece of wood that goes through it, and test it. And they can tell exactly if it's got the right amount of preserve in it and everything. That's why they can guarantee these things for like 30 to 50 years.
Back here with Gregory Grant. He's with BTL Engineering. They're the guys that both did the soil report here, and also they're doing the engineering for the piling capacities and the monitoring of the piles. So really kind of a critical job here, because if this stuff's not right, the foundation for this won't be right, and we could have a catastrophe. So it's important stuff. So Gregory, what are you looking for? I notice these are all different lengths, and there seems to be, you've got a report here that you're completing. What's going on?
Correct. I mean, these are 35-foot piles, and we're driving them down past the lighter materials that are up in the top 20 feet of the soil, and then we start taking a load count on how many times a 5,000-pound hammer drops from 6 feet, and how many times it takes for that pile to be driven an additional foot into the soil. Once I get up to a certain number of so many hits per foot, that tells me that we have enough load bearing on that pile that this building's been engineered for. So that's my main function, is to go ahead and make sure that they're actually getting the load bearing on each pile.
So we know that the capacity of each of these piles, based on the report, is 20 tons, and you're basically ensuring that the blow count that you get is going to get us to that 20-ton capacity.
Correct, 100%.
I see. So we just can't have the driver do this. Apparently, this is a requirement in Pinellas County to actually have it monitored by a company that will independently verify that each of these are driven to the proper depth.
Certainly.
So when we came out here this morning, the first thing I did is I came out and I looked and saw that they had started early with these setting these pilings, and there's actually two different lengths. The pool has 30-foot pilings. There's not as much gravity load on the pool, so the engineer called for 30-foot as adequate, and then the rest of it's 35s. But unfortunately, they had gotten started and they placed 35s in the back. So if you take a look at this truck over here, you're going to see there's 8 30-foot pilings, and those pilings can't be used for the house. So kind of got a little bit of a break in the action here, because we're trying to figure out how we're going to get the 8 pilings that we need for the house to either grow to 35 feet on the truck, or send the driver back to pick up the right ones. So that's what's going on. Pretty typical on a construction project. You always have to be paying attention, because unfortunately, as the general contractor, you're responsible for the results. You know, if you turn around, Derek, and grab a picture of that, you'll see those 30-foot piles up there. And had they been put in the ground, what likely would have happened is Gregory, through the monitoring, found that they were inadequate for that for the position that they were in. And what would the options been at that point in time once they were already sunk? And what would the protocol be?
If the pile comes all the way down and gets to the ground and doesn't meet the load count as required by the engineer, you have a couple of options. You can potentially do a sister pile right next to it. You can splice up on top of it.
Is there a sleeve for the splicing? Is that how that works, or it just goes right on top?
It goes right up on top of it.
Gotcha.
But at that point, it goes back to the engineer, my engineer, and he makes his recommendation. Do we go with the sister pile? Do we?
So it's more engineering, possibly, slows down the project. Not really what you want to happen.
More stuff.